Hey, let's get into what could possibly be the last thing you are going to learn in sixth grade. Math related. Anyways, what am I talking about? I'm talking about the mean absolute deviation. That's a lot of words there. Let's talk about each of them. So we know that the mean is that one number that describes all of the numbers, and it tells you like where the fair share is, remember, or the balance point. It's that if you have to look at all of these numbers and give me one number that describes it, here is that one number, right? But sometimes those means can be misleading. We've talked about outliers, how outliers kind of skew the mean to being a little less appropriate than what the data actually shows. So let me give you an example of what I'm talking about. So with this dot plot, the mean is 5. And you can see definitely the mean is that balance point right there. I can see how 5 would be the middle. Okay, but if we look at this set of data, set of data also shows that the mean is 5. And you can kind of see how, yeah, that could be the middle, the fair share, the tipping point, correct? But these two sets of numbers are completely different. This one is all clustered around the 5. This one has a huge gap between 4 and 5 and 6, and just two kind of separate sets of numbers there. So while the mean is very useful, sometimes it can be misleading. So it's too bad there's not a way to explain how like spread out the data is. Like, yes, you have your mean, but is there a way to show that that mean has numbers that are way far away or way clumped together? And that is why we're talking about the mean absolute deviation. So the mean absolute deviation tells how far a number has deviated from the mean. So let's talk about this word deviation. If you are deviating, it means you're going away from where you're supposed to go. Okay, so if you're like super on the path, then you're like straight, right? But if you deviate from the plan, that means you go away from the plan. So when we find the mean absolute deviation, we're seeing how far the numbers have deviated from that center point, from that balance point, from that mean number. Okay, so a small MAD, mean absolute deviation, when I say MAD, I'm talking about mean absolute deviation. If you have a very small MAD, it means that the numbers didn't deviate very far. If you have a big mean absolute deviation, it means that there's a big variation in how spread apart the numbers are. So looking at this set of numbers again, we have a mean absolute deviation of 1.8. That's how far away the average that these numbers are away from the mean. Here's our mean, right? And we can say that, yeah, most of the numbers are within 1.8. So they're all kind of clustered right there. Whereas this one, the mean was 5, and we can see the mean absolute deviation is bigger than that mean absolute deviation. It's 2.6, meaning the majority or the average that the numbers are 2 and 0.6 away. And you can kind of see, yeah, they're spread out way further than these numbers at 1.8 away. Okay, so this is what the mean absolute deviation is. It tells you how spread out your numbers are, how spread out your data is. Let me show you how to find the mean absolute deviation. So when I'm saying mean, I mean the average, right? Deviation, I'm talking about how far it's away from the mean, and absolute is the distance, right? So we're talking about how the distance and the numbers are away from the mean, okay? So what we're going to do, this tells us that the mean age is 10. So 10 right here is your mean. The first thing we're going to do is we're going to find the absolute value. We're going to find the distance that these numbers are from the mean. So all of these 8s right here, what are these? The ages of gymnasts. Okay, so all of these 8-year-olds are 2 years away from the average age. Do you see 8 is 2 away from 10, which means that this 9-year-old is 1 away from the mean. These 10-year-olds are exactly the average age of those gymnasts. These 12-year-olds are 2 years away from the average, and the 13-year-old is 3 years. So now that we've got the absolute value, the distance, the number is from the mean. What we're going to do is now find the mean of those distances. So we're going to take all of those distances and we are going to add them up. And even if there's zeros, we're still going to add them up because I did something wrong. Oh, too many zeros. We're still going to add them up because these are still girls. We're not just going to ignore them. Okay, so we're going to add them all up. 2, 4, 6, 8, 7, 9, 12, 9, 2, 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. Is that right, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good, 18. Okay. And then remember that we find the mean by dividing by the total number of numbers that we added up, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Just 12. So we're going to go 18 divided by 12. And that's going to give us 1.5. So that 1.5 is the mean absolute deviation. What that means is that, yes, the average gymnast age is 10 with a mean absolute deviation of 1.5 years. So majority of the girls that are gymnasts, or of the gymnasts in general, they're all within 1.5 years of the 10-year-olds. So we have the 10-year-olds, but most of them are like 1.5 years older or 1.5 years younger. That's what the mean absolute deviation shows. Okay, and that can give us lots of information. For example, with these two teams, the number of magazine subscriptions sold by 2 teams of students for a drama club fundraiser is shown below. The mean number of subscriptions for each team is 4. So let's say that they had a competition, right? Whichever team had the highest average number of magazine subscriptions sold was going to be the winner. And we have team A and team B, and they both had a mean of 4. So on average, they all sold about 4 magazine subscriptions. Well, what are you going to do then to figure out who the winning is? Okay. Let's see if finding the deviation helps us at all. Okay. So team number 1, there were 2 people who sold 1 magazine, 1 person that sold 4, 2 people that sold 5. Then we have team B. There was someone who didn't sell 1 at all. Someone sold 0 or 1. There was someone that sold 4, someone that sold 7, someone that sold 8. So just by looking at this dot plot, we can say that these guys deviated less from the mean than these guys. Okay, we can see that 4 is your mean. And just looking at it, we're going to know that this mean absolute deviation is going to be smaller than this one because there's less variation, there's less of a spread. But we're going to find out what that number is. Okay, so if the mean is 4, then these guys are 1 away. That's exactly the mean, and that's 1 away as well. So we can go 1 plus 1 plus 0 plus 1 plus 1, and that gives us 4. 4 divided by 4. No. There weren't 4 people. There were 1, 2, 3, 4, 5 people on the team. 4 divided by 5 is 0.8. So they're all like within 1. 0.8 is the mean absolute deviation. That's very small measure, like number of deviation, right? Let's go to team B now. So the mean is still 4. That means that one's 4 away. That's 3 away. That's 0 away. That's 3 away. And that's also 4 away. So we've got 4 plus 3 plus 0 plus 3 plus 4, which would give us 14. 14 divided by 5 is 2.8. So that's way more than team B. So what that shows is that team A was a little more like consistent. They were a little more all on the same page. They didn't vary much from the mean. Whereas team B, they were way more spread out. And that could show you that, yeah, there was a bigger group that sold a lot and a bigger group, another group that didn't sell anything at all. So knowing that information now, could you, if it was up to you, choose a winning team? Okay, that is just another way to look at some information, some data. You're making me nervous. Why are you staring at? Do you want to say goodnight?
No, sure.
Okay. What time is it? Don't answer that.
It's 9:56 because we were watching Top Gun.
Okay, you were watching Top Gun.
Dad and me were.
Okay, love you. Good night. All right, so we have got the number of laps that Shauna swam on 5 different days and the number of laps that Laura swam on 5 different days. So it can also kind of show us who's more consistent. If you have a mean absolute deviation that's small, it means you're kind of staying with the same numbers. If you have a large mean absolute deviation, it means you're kind of like spread out all over the place. So we can find out which of these, Laura or Shauna, are more consistent or more like keeping everything the same. Okay, so Shauna was 5 laps, 6 laps, 6 laps, 8 laps, 10 laps. And Laura was 1 lap, 3 laps, 7 laps, 11 laps, 13 laps. That was really good of you, Mrs. Madsen. Really helpful. Okay, so back to Laura. Do we know the mean? Oh, good. We know the mean is 7. So they both average 7 laps a day. Okay, who is more consistent though? So that's 2 away from 7. That's 1 away from 7. 1 away from 7 and 3 away from 7. So 2, 1, 1, 1, 3, 3, 4, 5, 6, 7, 8. 8 divided by 5 days, right? So 8 divided by 5, 1.6. So that seems like a fairly small mean absolute deviation. Let's go on to Laura. Hers was, 1. So what's our mean? Mean is still 7. Okay, so 1 is 6 away from 7. 3 is 4 away from 7. That's right at 7. 11 is 4 away, and 13 is 5 away. So we've got 6, 4, 0, 4, and 5, which will give us 19. We're going to divide that by 5 because you add and divide for the mean. And that will give us 19 divided by 5, which is 3.8. So much larger mean absolute deviation. So by looking at these mean absolute deviations, we can definitely see that Shauna is the more consistent swimmer, swimming the same thing more often than Laura. Laura is very spread out in how many laps she swims. Okay? All right, let's do one more. Why don't you try this one on your own? So this one's, it's nice because it already gives you the mean. If the mean is 7, which I can see how that's the balance point, right? The average. What is the mean absolute deviation? Try it on your own and then come on back. Have I made any mistakes yet? This is actually a second video that I did because last year I made some terrible mistakes to the point where it's like, oh, I just need to start over. All right, so maybe I've already made a bunch of mistakes. Maybe I haven't. And this is big enough that I'm going to use a calculator and move my face. All right, let's compare what you have to what I have. 3 plus 2 plus 2 plus 2 plus 2 plus 1 plus 2 plus 3 plus 3 plus 4. Okay. Yeah, 24 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10. Let me make sure that's the correct number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that sounds good. 24 divided by 10 is 2.4. Did you get the same thing I did, or is this where I made mistakes? Let me know. That is how you find the mean absolute deviation. You find first how far the numbers have deviated from the mean, and then you find the mean of that. So you find the average of the distances that those numbers are from the mean. Not really something that I'm super worried about you knowing. In the future, you're going to start hearing about standard deviation, which is used very much. This is kind of preparing you for the next step in middle school and high school for standard deviation. Anyways, side note, awesome job this year. You've learned a ton. So proud of you.